Welcome back for the videos for chapter 7. We are going to take what we learned about square roots in previous chapters and apply them to combine them for some necessary things in looking at quadratic equations. So the first thing we need to know is the square root method. So the square root method is going to be one way for us to help solve for a value when we have just a single squared item. So if we have an item that's squared and we want to find out what that is when it's equal to a value b, then we can take the square root of both sides. And that means we will have the positive root of b and the negative root of b. Okay, so for this situation, because we're talking about possibilities of the square root, there is a positive and a negative. Now, when we talk about a function, we can't have a negative of the square root. So we'll deal with that later. But for now, we're going to treat it as there's a positive and a negative value. So I want to find x. When I square x, it equals 16. So if I take the square root of both sides, then I get that x can equal a positive 4 and x can equal a negative 4. The square root of 16 is 4. Now, I am going to look at b. I want to take a number that's squared and it equals a negative 49. So if I were to take the square root of both sides, this is where I would come up with the issue of I can have a positive and a negative root of a number, but I can't have a positive and a negative root of a negative number because there's no two numbers when I multiply them that would give me a negative 49. I can have 7 and 7 would give me a positive 49, and a negative 7 times a negative 7 would give me a positive 49. But there are no two numbers that would give me a negative 49. Okay, let's look at C. So C says we want to find x, but I need to isolate x. So I'm going to subtract 8 from both sides. And now if I wanted to apply this rule or this property, I cannot do that because I would be taking the square root of a negative number. So again, that won't work. So let's look at D. Okay, I want to isolate the x squared. So I'm going to add 20 to both sides. And then I'm going to divide both sides by 9. And before I do that, I'm going to just go ahead and take the square root of both sides. And we can take the square root of 20 over the square root of 9. And that gives me the square root of 20 over 3 and the square root of 20 over a negative 3. Because remember, the square root of 9 could be a plus or a minus 3. Letter E. I have a thing squared. So to get at the inside of this thing, this 3x plus 7, I'm going to square root both sides. So if I take the square root of this side and the square root of this side, then I have the 3x plus 7 equals a negative 1, and 3x plus 7 equals a positive 1. And then I'm just solving for x on both of these. So I'm going to subtract 7 from both sides and divide by 3. So I have a negative 8/3. I'm going to subtract 7 from this side as well, just like I did on the left, and then divide by 3. So a negative 6 divided by 3 is a negative 2. Then on F, again, I have a something squared. So I'm going to square root that And then I'm going to square root over here. But again, I'm trying to take the square root of a negative 75, and I cannot do that. So there's no real solution. Okay. So building on this idea is something called completing a square. So completing a square means I ideally want to have something that is a perfect square. I want a perfect square. So a perfect square would be x squared plus 6x plus 9, meaning that factors into a perfect square of x plus 3 times x plus 3, or x plus 3 squared. So when I square root that, I've just got x plus 3. So that's ideally what we want to have. So sometimes we have to create a perfect square to get to this idea. So the first thing we're going to do is we're going to write the equation. We're going to move any constants to the right-hand side, and we're going to be left with a single ax squared plus bx. If the leading coefficient is not 1, so if a is not 1, we're going to divide both sides by that a. So that means ax squared will get divided by a, bx will get divided by a, and c will get divided by a. Then we're going to add the square of half the coefficient of the linear term to both sides of the equation. So that means we're going to take b divided by 2 and we're going to square it. So half of b squared, and we're going to add that to both sides. Write the left side of the equation as a square of a binomial, so a perfect square, and simplify the right side if possible. And then you can go ahead and apply the square root property for equations and solve as usual. So we're just going to get practice completing the square. So here I want to add something to get a perfect square. So I'm going to take b is equal to 6. So I'm going to take half of b and square it. So that would be 6 divided by 2 and square that, which is 3 squared. So I'm adding 9 here, and I'm adding the 3 is going to go here, because x plus 3 times x plus 3 is x squared plus 6x plus 9. Let's just practice here. So this is going to be, what goes there is b divided by 2 squared, and what goes here is just b divided by 2. Okay. So in this case, b is equal to a negative 2. We have x squared minus 2x. So b divided by 2 squared is a negative 2 divided by 2 squared is a negative 1 squared is 1. So this is going to be 1. And then my b divided by 2 is just a negative 1. So that's the 1, x minus 1. Let's look at c. So c is x squared minus 8x. So b is equal to a negative 8. So b divided by 2 is a negative 8 divided by 2 is a negative 4. So that's why this is x minus, it's the minus 4. And so what we add here is the b divided by 2 squared, which is negative 8 divided by 2 squared. Negative 4 squared is 16. So we're adding 16. Notice it's always adding something positive here, because even if b divided by 2 is negative, when we square it, it becomes positive. But when it's in a perfect square, it'll still be the negative, the x minus 4. Let's look at D. So we want to see that b is 3. And so b divided by 2 is 3 halves. And that's what goes here. And then b divided by 2 squared is 3 divided by 2 squared, or 9/4. And so that's there. Okay. So we're going to use this idea of completing the square to actually solve an equation. So let's do that in example 3. So we have x squared minus x minus 8. So to complete the square, we are going to take b is equal to a -2. So we're going to take half of b. So a -2 divided by 2 is a -1. And so b divided by 2 squared is a -1 squared, and that's a +1. So that means I have to add 1 on the left, and I have to add 1 on the right. Because I added 1 on the left, I have to add 1 on the right. So now the left-hand side factors into this perfect square, x minus 1 times x minus 1 equals 9. And now I have a something squared equals a positive number. So I can take the square root of both sides. And when I do that, I get x minus 1 equals a -3 and x minus 1 equals a +3. And then to solve for x, I'm going to add 1 to both sides. So I get a -2 and a +4. Those are my two solutions. And catch me back for another video.